Hi guys, good morning. Hi guys, I am audible guys.
Yes, audible.
Okay. So again, I'm repeating the same thing what we have discussed in our last class because due to some network issues, some people might not receive my voice. Okay. So the topic is indexes, guys. So in generally in SQL, the index why the indexes will be used is to increase the performance of a query. To increase the performance of a query while retrieving the data. Indexes are used to increase the performance of a query while retrieving the data. While retrieving the data from a, I can say data from a table or tables. Indexes are used to increase the performance of a query while retrieving the data from a table. Okay. Now we need to know how the indexes will increase the performance. How the performance. So generally, you know about the indexes in book, right? Every textbook has its own index. So if you want to go for, if you want to search for any topic, first you will go to an index page and there you'll find the page number against the topic and then you'll directly go to that page, right or not?
Yes.
If you don't have an index in your book, what you will do? You have to keep on searching page by page till you reach your topic. The topic might be in middle or topic might be in the end. So somewhere it is. So, but you need to search full book or not. So in the same way, here as well. So index will increase the performance while retrieving the data. So how the performance, where you are seeing the difference in? So if you have an index, your search is less, right? You don't need to go and search each and every page. Without index, what you need to do? You need to search all the pages, right? So it will increase. It will increase number of searches or not? With index, you no need to. You will minimize the. Got the difference between two, guys? So here, without index, I'm just first talking about the book, guys. In a book, if you don't have an index, without index, what you need to do to get a topic? You need to search for all the pages or not? What it will do if you are searching for all the pages means, suppose in your book you have a 400 pages, you need to search all the 400 pages, right? So that's what I'm saying. It will increase the number of searches. You need to spend 400 searches here. But if you have an index, so what you will do, you will directly go to the index page, and there you will find that your topic name, and against the, you'll take the page number against it, and directly you'll go to the particular page. So what it will do, it will minimize the number of scans or not. You don't need to go search for entire book. It will minimize the number of scans or not. So when you have a proper index available on your book, so it will be easier for you to find the required topic. Here also in the SQL Server indexes. So if you have a proper index created on a table, so it will decrease the number of scans. If you don't have an index created on table, it will perform a table scan. Table scan in the sense, it will search for all the records in a table. So suppose guys, here I like type. So we have a table called employee, right? Select star from employee. While creating this table, have we created any index on this? Have you ever used to create index name, something like that? Have we ever used in our past classes? No, right? So this is the table without index. Suppose when I am doing this, select star from employee where DEP ID equals to 2001. See, here I'm just trying to get the data for department 2001. So what it will do is, since there is no index, SQL engine is not having a proper structure created. So what it will do is, it will go and check each and every record available in this table. It will go and check how it is. See here. These are the records from employee table. How many records are there, guys? 14 records. If you exclude header, we have a 14 records. So this such, it will come to each and every record exists in a table. So this is 2001 equals to 2001. Matching or not? Yes, it is matching. 2001 equals to 3001. No. 2001 equals 3001. False. 2001 equals to 2001. Yes, true. 2001 equals 3001. False. This is false. False. True. False. False. True. False. True. False. This is how this will do such a complete table scan it will perform. So here how many records will come? 2, 3, 4 and 5 records will come. Just run this here. And so if you want to know here, the execution plan is also there. So SQL engine will get, so whatever the query you have written, based on the table stats, it will provide you the best execution plan. Suppose if select this query and click here, you have a display estimated execution plan, Control L. So just run this. So here it will show you what is the best plan the SQL engine is choosing to run your query. It is performing table scan because there is no index created on this table. So there is no index. What you are doing in the book, you have to search every page in the book. So in the same scenario here. So in SQL Server, we have a concept called table scan. So when there is no index on a table, it will perform table scan. Table scan means, see, actual output is 5 records, but here it is reading 14 records. See, estimated number of rows to be read is 14. Estimated number of rows for all executions is 5. It is returning 5 records, but to return those 5 records, it is reading all the 14 records from a table. So that's why we call it as table scan. See, physical operation it is performing is table scan. Okay. With index, I will show you with index what will happen, how the number of searches will be minimized, and what is the method that is using. Okay. Okay. So next, first what we'll do is, the table without index is called a heap table, guys. the table without index. If the table you have created without any index is called a heap tables. So if you are performing any such operation on a heap table, it will perform full table scan as I shown you now. Okay. Okay. Let me show you an example, guys. Okay. Here I have a document. Let me show you an example. So this already we discussed and we'll come this later. See, how will be the database engine retrieves the data from a table? How the data will be retrieved from a table by SQL engine. So there are two ways. By performing table scan or index scan or seek. It will use, SQL engine will use either of these. Either of this. When it will go for a table scan, when it go for an index scan, index seek, I will explain you now. So what is the table scan, guys? Already we have discussed the table scan is, I'm just reading out here. While retrieving the data from database tables. Retrieving in the sense, you know, right? Select star from employee, which means I'm just retrieving the data from employee table. Okay. Retrieving in the sense, I'm just select star from employee means I'm just retrieving the data from employee table, which is the retrieving, we can say. While retrieving the data from a database tables, the SQL server search engine will search for the required information sequentially, one by one from the start to the last record of a table. See here how we did is, this is how the table data is available in the table. So how it is searching, it is start searching from the first record to last record. That's what I'm saying. Information sequentially one by one from the start to the last record of the table. If the table is having more rows, then it will take more time, right? Here we have a 14 records. It will not make you a big difference even if you create index or not creating, because very less amount. But in real time, you will be having a millions of data available in the table. So there it will make you impact. Okay. So it will make more time for searching the data. So it is what? It is a time consuming process. So if the index is not created on a table, then default mechanism used by the SQL Server table is table scan. If the index is not created on a table, the default mechanism SQL engine follow to such a records is table scan. By default, it is a table. So by default, in the sense, if the create table is not having any indexes, it will go for table scan. How it is? So let's say in my table, I have a 1 to 50 records. So suppose you want to search for the value 50, then the SQL engine will scan the record sequentially one by one from the beginning, which is from 1 until it reaches 50. If you want to increase the search performance, means what you need to do? You need to minimize the number of scans or not. That's what we have discussed here. If you want to increase the performance of a query, what you need to do is to minimize the number of scans. So if you are not having any indexes, it will go full table scan, which means how many records were there in the table, that many scans will be available. But so what you need to do if you want to increase the performance, you need to skip unwanted searches, which means you need to minimize the number of searches, which will give you the performance more. So how we can do that is, that's what I am saying. If you want to increase the performance, then somehow you must minimize the number of scans. That is what exactly B3 indexes will do. So if you want to minimize the number of scans means, what you need to do is, you need to just create index on a table. Okay. So then it will increase the performance of your query. So how it will increase the performance of your query and how the number of scans will be minimized, we'll see step by step. Next, guys. So index table scan. The next thing is index scan. Index scan is, in index scan, the SQL Server engine uses. So index scan in the sense, if you create an index on top of a table, so then this will use index. Then this will use index scan, either index seek. Okay. So SQL engine will use that mechanism, index scan or index key mechanism, to search the data faster from a table. How it will search is, so when you create an index, so SQL engine by default will create balanced tree structure. balanced tree structure. So what mechanism it will use to minimize the number of searches is, so if you are creating an index means it has to follow some mechanism to minimize the number of scans or not. It has to follow some mechanism. So what mechanism when you are creating an index, it is following is balanced tree mechanism. So balanced tree algorithm is there. So based on the balanced tree algorithm, it is searching the data and from a table to minimize the number of scans. So in the same example, guys, here if you see the diagram, so now here also I want to search for so search for the 50th record. 50th record. So internally balanced tree structure, how it will define is, see, it is whatever the data which is available in the table, it will be treated into like this: root node, non-leaf node, and leaf nodes. Which means suppose 1 to 30 is 1 to 50 records is there. So root node has the high level information, which is 30, 50. Non-leaf node has a information of these 30 records, 10, 20. 50 is a 40, 50. So, and leaf nodes has the actual data. Leaf nodes has the actual data. Root node and non-leaf nodes has the information about this actual leaf nodes. In the leaf nodes has whatever the data is there in the table, actual data will be there in the leaf nodes, guys. Please remember, in the leaf nodes, you will be having an actual data, and in non-leaf nodes and root node, the high level information about those leaf node data will be available. See here, 30, 50, 30, 10, 30, 40, 50. Why this information is here is, it is distributing the data balanced in the balanced way. So balanced way, what it will do is, suppose you are searching for select star from EMP where employee number equals to 50 for now. Just think of it. Select star from EMP where EMP number equals to 50. So when you create an index, so as I said, it will follow the balanced tree structure, and internally the data will be structured in this way. So first our SQL engine will come here. The 50 is here or here. 50 is there in this. So there are two separations. There's in the left side, or 50 will fall in the right side. Which
Right.
side of this, guys? 50 is falling. Right side, right?
Yes.
So it is right side. So the 30, this complete, this is bypassed. This 30. So this, if the 50 is not there in this left side and left hand side, right? So what is there in the hierarchy of 30? How many records are there in the total 30? Out of 50, in the first search itself, we are removing 30 scans, right or not?
Yes.
30 is bypassing, and next it is coming to 50, and 50 again divided into two parts: 40, 41 to 50, 40 31 to 40, 41 to 50. Now here your 50 is in the left or right?
Right.
Right. So left is again decommissioned, right or not? So
Yes.
by performing two searches, how many records you are bypassing? Total 40 records. These 40 transactions we are bypassing, and we are not doing any scan for these 40 transactions. We are left with 50 is available here is, we are left with these 10 transactions. We'll check in this left 10 transactions, and it will provide a, instead of having a 50 scans, what it is doing is, it is performing 10 to 12 scans. Without index, it is performing 50 scans, right? With index, it is performing only 10 to 12 scans. Or if you have proper index, it will come with a one read as well. Okay, see here, in these only 10 records are scanned. Only these 10 records are scanned when you have created a proper index. So which means instead of 50 scans, you minimize to 10 scans, right? Which definitely increase the performance or not?
Yes, it will.
This is a difference between table scan when you create an index and when you not created an index. So how the index will, so how I can say the index will increase the performance is, the better way you need to minimize the number of scans, which is doing by SQL engine. How will you do is, by creating an index. What index will do is index will use B tree structure mechanism to minimize the number of scans. Okay. How it will, the mechanism it will follow is this, like this. So we'll show some examples. Here I have written a theoretical, guys. You can read it. I'll share this document to you, upload it. Okay. Let me create this table and we'll follow. Okay. I'm just dropping an employee table size. Table already employee table is there. I'm just dropping those that employee table. Okay. Now I'm creating a new table with the ID, name, salary, gender, city, and department. Okay. And I'm inserting the data. Okay. Let me insert this data. So 8 record inserted. Do select star from the employee. Okay. Next. So we have not created any index on this table, guys. Just select star from employee. We have created a table and we inserted some data. So that's what I'm saying. Currently, we don't have any index and any in the table. So what we'll do is, so I'm just trying to execute this query. Select star from employee where ID equals to 8. So without index on a table, what I have told you guys, it is a table scan. Sorry, it is a heap table, and heap table it will perform table scan. So see, I'm just searching for 8. See, one more thing, guys. Observe the data, how it is loaded. The data you are seeing, this table is in ordered, or how you are inserted in the same way it is there. The same way you have inserted. The data is arranged in the table. How you have inserted 3, 1, 4, 5, 7, 6, 2, 8, 10, 9. Okay. Just keep remember it. I will show you where it will impact. Okay. See here, you are not seeing a much performance issue, guys, because very less data we have. But if you come here and you will check the execution plan for this, it is performing a table scan, and how many records it is reading is total 10 records we have inserted, right? So it is reading 10 records. Estimated number of rows to be read is 10, and estimated number of rows written is 1. For returning 1 record, it is reading 10 records. Total records in the table. Okay. Then, so what is the way? Next. See. Next, what I'm doing is I'm just creating an index. I'm just creating an index to increase the performance. So far, what I am telling you guys, index to be create. If you create an index on a table, I'm just mentioning table only, but that is not directly created on a table. So index to be created on a table columns. Okay, creating index. Index to be created on a table columns. Okay. Select star from employee. Here is the question. Next question, guys. So I have these many columns. On which column I need to create an index?
ID.
ID.
Why I am creating the index is on ID?
It is a unique record.
Index to be created on a columns which are frequently used in where class, guys. Which are frequently used in where class or join. Okay. Join. Well, okay. In this case, those columns will generally create an index. Okay. If you are creating a index on all the columns, it will decrease the performance, guys. Okay. Index to be created on columns which are frequently used in your where class. Suppose here I am just searching for ID, so you have told me that ID is the column and we need to create an index. But in real time, you will be given the different table. But based on the table, you need to understand what is the column might be you are frequently getting used. So that on that columns you need to create an index. Okay. Now create index. I'm just creating a. Okay. Before this, guys, just check how the data is there. Do you see any particular order? The data is in any particular order? No, right? Create clustered index. IX. I am creating an ID, right? I am just giving ID for our better understanding. Okay. On create clustered index, index name on table employee of ID column. Employee of ID column. Create clustered index. So only for clustered index, we'll keep the keyword clustered, guys. Otherwise, simply create index, index name, create index, index name on table of column names. You can create a cluster index on multiple columns as well, separate by comma. Okay, separate by comma. Okay. So now I'm done with just select, click on execute. So now command completed successfully, which means I have created a cluster index on employee table. How to check? So are available on a table or not. Okay. Execute sp help text. See here, guys. Do you see any? See here, index name we have created is IX ID and cluster index we have created. So by using this command, we'll come to know the index is created on a table or not. An index. Okay. Next. Now the index is created, right? Just see the data in an employee table. How is this now? Before, how the data is there in the table before creating a cluster index, after creating cluster index, what is the difference you see? You observed. Just tell me.
ID in sequential order.
The data is arranged in a
sequential
sorted order. Data was sorted. So that's the point you need to remember, guys. When you are creating a cluster index on any particular column or multiple columns, so how the sort will work, you know, right? When we work with operations and join operator, we have used the sorting, ascending, descending like that. So how the data will be sorting on single column or multiple columns, the same way here as well. The data will be sorted in a particular order. So cluster index will not create any separate object, guys. What the cluster index will do, it will reorganize if the data is not in a particular order on that particular column. So what it will do is it will reorganize the data within the table. It will reorganize the data within the table. So what might happen if the data is in a proper order and you are using this column in a search operation, the data is in a sequential. You can find the data. So if you see a simple thing, guys. So I have a place, thousands SFT place, and there I have clubbed all chairs together with red, blue, green, or different colors. Okay. Not in a order, guys. It was there like a mix. Okay, I have asked you to bring only red chairs into the room. So what you will do, you have to search, right? You have to search where the red color is and you have to find and you have to take it and you have to keep it in the room. It is a additional process or not. But if even in outside, the day, so first red chairs are there, next green chairs are there, next blue chairs are there, next the some different color chairs were there. So if I ask you, you can directly go there and you can start picking it or not. Because the chairs are in a order of their color. And here the data is in order of their ID, which we are using in where class. See here, select star from employee where ID equals to 8. Same query I'm running, guys. Same query I'm running. So just go and check estimated execution plan. What it is seeing, what is now? It was changed from table scan to cluster index seek, right? Index seek. Just keep a cursor here. How many number of rows it is reading to get your 8, the record?
One.
One. Earlier, how many scans it is performing? How many reads it is performing?
One.
Before index creation, it is reading 10 records to give you the output. Now it is reading
One.
only
One.
one record. You are seeing a difference, right?
Yes.
That's where it will increase the performance. Okay. Here, you have very less data. Even if you run with index, without index also, it will give you the same output, same number time. But when you have a large amount of data, you will make the difference. Got it, guys? What is the index and how the index will increase your performance? Okay. If you are not creating index on a table, what is the default scan it will perform is table scan. If you're on your table, if the index is not there, we call it as heap table. This table we call it as index table. Okay. How to know whether the index is created on a table is this. Okay. Any questions so far, guys? Okay. Thank you. Next. See, everything what I am just explaining you with the diagrammatic representation is here, sir. Guys, I'll share you. There are two types of indexes in SQL Server is available. One is cluster index and the other one is non-cluster index. Cluster index is already we discussed. Right? Cluster
Yes.
index is already we discussed now. Okay. And we need to discuss non-cluster index. Let me do this. So what I am doing is the same table, how to drop index on a table. So drop index name on employee. Drop index name on employee. This will drop index. Now the index was dropped. Cluster index, what I have created on a table was dropped. Now you see the data. See, because it is already arranged in a order, so it is showing in order. Now just run this query and check. Executed as estimated execute plan. It is performing table scan. See, number of rows it is returning. Reading is 10 because the index was dropped. Index was dropped. Okay. Next, creating a non-clustered index. Create index name ixid. So you are not keeping any keyword here, right? Which is a non-clustered index. The above, when I am creating a clustered index, I have mentioned a clustered. Here I am not mentioning. Create index name, same on employee table ID. Employee table ID. See, now the index is created. Now run this query. Now run this query. Come here. What it is performing? You have created non-clustered index. What it is performing? See, still it is reading 10 rows, though you have created an index. So when you are creating a non-clustered index, what it will do is it will create a separate database object. It will create a separate table called index table. What it will do is it will create a separate table with all the IDs. Okay. So whenever you execute this query, first it will go to the index table, and from there it will search for the 8th. Same tables can have, since the data is a distinct, it will take the same time. But if you want to make this more effective, you need to create a non-clustered index on the clustered index table. If you perform the same thing on clustered index table, it will increase you the performance. But if you are creating a non-clustered index on the ID column, which has a distinct values, it will not make you big difference. Here, cluster index already we have discussed it. The cluster index and SQL Server define order in which the data is physically sorted in a table. So when you are creating a clustered index on a table, it will not create any separate index table, guys. So what it will do is whatever the data is there inside a table, it will physically sort the data in the within the table itself. Will physically sort the data within the table itself. So cluster index has this cluster root node, intermediate node, and actual data. This is called as leaf nodes. See, already we have seen this example. Non-cluster index. So non-cluster index has a different architecture. See, guys, if you are creating a non-cluster index on a clustered index table, it will perform in the one way. If you are creating a non-clustered index on a clustered table, it will perform in a different way. See, if your non-clustered index is created on a clustered index, the same how the cluster index is splitting the data and getting this. If you are creating a non-cluster index as separately, see, it will perform heap table. It will treat as a heap table and it will perform row scan. So, but the creation of index and dropping of index is in the same way. Creation of index. The command to create index is, if it is a clustered index, you need to mention create clustered index name on employee table. And non-clustered index means create index name on employee of ID. So the same thing, only this keyword is changed. But while dropping means drop index name on employee, both. If it is a non-clustered index or clustered index, it doesn't matter. It will help you to delete, drop the index permanently from the database. Drop is the command which can be used to drop your object permanently from the database. Object in the sense it is a view, or it is an index, or it is a table, or it is a procedure, it is a trigger, or it is a function, anything. If you want to permanently drop from the database, just use a drop command. Okay, guys, this is what index about, guys. Indexes. So here you need to know is first in the, so you, since you are not developers, right? First you need to know what are the types of indexes available. So first thing, the table, if you have been given the table, first you need to know whether this table has an index created or not. So this will help you to find the index is created on a table or not. First thing. And second thing, you have been asked to create an index. Which index I need to create? It will give you the better performance if you create a non-cluster index on top of cluster index. The first one better is, foremost better is, first you need to create a cluster index. You need to understand what is the cluster index. Cluster index is what cluster index will do. Cluster index will reorganize the data in a physical order within the table itself. Okay, so that it will perform an index seek. So the search engine will be search will be faster. Okay, so here only one thing you need to remember, guys. The cluster index can be created on a, only one cluster index can be created on a table. It will not allow you to create multiple cluster indexes on a table. So SQL engine will allow you to create only one cluster index on a table. So once a cluster index is created and data is arranged, then on top of it, is there any multiple columns you are using in such a condition? Then you create a non-cluster index on top of it. Non-clustered index. You can create a multiple non-clustered indexes like this. Okay. Suppose here in the same way, if I create CLI clustered index, I'm just rename. So the same name can't be given, guys. That's why I'm just change the name. Create. Here I'm just saying clustered index. I'm done with creation. Now check what it is performing and how many it is reading. This. Okay. How many number of reads it performing is 1. Suppose, let me check what is the department. So what I'm doing is I'm just creating one more index. Create non-clustered index ix underscore hr. Sorry, not DEPT on table of employee of DEPT. Yeah? This is the column name. DEPT. I'm just creating a one more index on DEPT. Now created. So here instead of ID, what I am using is on cluster index table, I have created a non-clustered index. DEPT equals to HR. Just see now and take the executed estimated plan. It is performing index. See, earlier it is performing index seek, guys. Why? Because you are using the column which is used in clustered index. And here what are you doing is on clustered index table, you have created a non-clustered index on DEPT column. So that's why it is performing index scan, not index seek. So when table scan will perform is the table without index. If you are retrieving the data from table, so it will perform table scan. That is the table scan. When index seek perform is if you are using clustered index column in your search criteria, it will perform clustered index seek. But when index scan will perform is on clustered index table, if you created any non-clustered index on any other column, then it will perform clustered index scan. See, here it is performing clustered index scan. And how many rows it is reading, guys?
4.
It is still reading 10 rows, but the 10 rows will be quite faster. And in this case, you need to see the IO cost, input output cost as well. IO cost, CPU cost. So always you should not be based on this number of rows to be read. You should also check for estimated IO cost, estimated CPU cost. Okay, that also you need to check. So this is what about indexes, guys. Anyone has any questions? So this will be not confusing, but theoretically it should be, but practically we don't have any data to be shown here. This is where increasing the performance. So only the place before executing, if you want to increase the performance means you need to go here and you need to check what is the star city. Is it performing index key, index seek or index scan, or what is performing? If you want to make index seek will give you a better performance. So you need to find the way to rearrange your query to get the data in index seek. If it is not possible, then you don't have any option. You need to arrange the data in a data. So when it comes to the performance, guys, it is always hit and trial. It is always hit and trial. Though you have created index and everything in proper, also I'm not give you assurance that it will increase the performance. If the performance has to be increased, means there are a lot. There are a lot. Just a moment, guys. Someone is asking, can we create an index and view? Yes, we can create an index and view, but there is a different. We can create index and view. We can create. But there with the schema binding, you have to create an index with view with the schema binding. Then only you can create a index and a view. With the schema binding keyword will be there. When you are trying to create a key, view, so you have to create view name with the schema binding as, then you can create index and view. Okay. So I'm just trying to explain this. Even if you create an indexes and everything, it's not 100% that you will get a better performance. Why? Because suppose, guys, I have my personal laptop. My laptop will support 12 GB RAM. I just wanted my laptop to become faster. So what I did is I just purchased a 12 GB of RAM and I just inserted. So will it increase your performance? So performance of your laptop will be based only on RAM, or is there any other also will impact?
RAM.
Motherboard, processor, these are also will be part of increasing your laptop performance or not?
Yes.
Yes, yes.
These
And the
also,
data also matters. And the data also matters.
yes.
How much data was there in the
It is always not matters that if you simply go and increase the 12 GB RAM so that my laptop will become faster. No. So you have to, so whatever the RG, so the supported 12 GB RAM supported motherboard and processor would also be available. So if that is only the case, the new laptops which comes in the market, they simply will increase only the RG, right? This is 2 GB laptop, this is a 3 GB laptop, this is a 12 GB RAM laptop. Simply they can increase the RG and can release it in the market, right? But every new version will be increasing a motherboard and processor, Android version, everything or not, along with the high RAM speed. Okay. So here also the same case. So if you want to run this and you need to have a space available and you need to have a application layer. So application layer, database layer, administration, everything should be in a proper place. Then only it will increase the performance. Okay.
Krishna, you said we can create only one cluster index on the top of table, right?
Yes.
So can we alter and change the columns in the cluster index?
Alter is not preferable, guys. So if you want to create index on multiple columns, means just drop a index and recreate an index. That will not do any impact.
Okay.
Okay, it's a better is, even if you alter it will not give you a better performance. Why? Because see, the data is already in a structured way, but if you are simply adding a column, will not make you a difference. If you are if you are recreating, means it will reorganize the data, which is entirely rebuild.
Okay. Got it.
So, and that too, one more thing you need to remember is once you create an index, that's not more than sufficient. So see, as and when daily you will be performing DML operations, right? You will be deleting, inserting, and updating the data.
Yes.
Whatever the data that you have created in index, the data will be, there is a chance of getting changes. So then
Yes.
index will be, so defragmentation we can see. The data will be defragmented, which needs indexes to be updated. Okay. So based on the DML operation that you are performing on a daily basis, so you periodically should either reorganize wherever the data changes, you need to reorganize the indexes to include that data as well to the index part, or you need to rebuild the index. Either of these two performed. Okay. In the real time. So that is all not in your hand, guys. This is all be done by DBAs. Reorganizing, defragmentation, and rebuild the indexes. So this all will be done by DBA team, not by you. Okay.
Suppose we have created an index and materialized views. So then materialized views can be updated every 4 hours or 6 hours based on the schedule, right? So
Yes.
in that case, the data will be automatically updated, right? So did we need to rearrange or recreate the
Cluster
clusters
index,
in that case?
every time it will reorganize the data, guys. So there is nothing to do with the cluster index. But non-clustered index you have created to be rebuilt.
Okay. Okay.
Okay.
Okay.
Any more questions, guys?
Can we create an index and primary key column?
Yes. See, so
Because
when you created a primary key, I have shown you automatically it will create a cluster index. If you create a primary key on a table, any of the column, it automatically will create a cluster index, because the primary key will not allow any duplicates. The data will be stored in a order only. It will automatically create a cluster index, guys. So you don't need to create any index if you are creating a primary key on a column.
okay.
You can check once you created a primary key, and then I have shown you right as exec sp_ help table name. It will show you the index created on that column.
Okay.
Any more questions, guys?
No question.
Okay. Thank you. So we are left with the procedures concept, guys. As a regular batch I am teaching, I'll be teaching till procedures. Okay. So how do you want them? So so I'm planning, not very soon I am planning, guys, but in this month only I'll plan, but after 20th only. So you want me to complete the procedures and everything along with that sessions, or now you want me to explain the procedures now and continue the same again after? So how do you want? Because none of the batches have teached exceptions, functions, triggers, but I'll pass a message to everyone who is interested to join. Everyone will join, not only this batch, but every batch I'm just including procedures in the regular batch. Anyway, let me finish the procedures. Even my part is getting delayed also is not a problem. I'll intimate you guys through Mahesh about that sessions. Okay. Because I
Sure.
can start from the coming weekend, but I have my kid first birthday in this month. I might be available, not might be available. So
Okay.
okay. Okay, guys, and tomorrow I might not be available, guys. I'll inform you about tomorrow and after tomorrow class. Tomorrow I have a small function is there, and I'll be traveling to Hyderabad tomorrow night or day after. So if I am available day after tomorrow, I'll page you, and I will take a procedures class, so that we'll be done with the batch. And what about again, I'll teach procedures, functions, triggers. Okay, no problem.
Okay.
Krishna.
Okay, thank you, guys.
Thank you.
Thank you.
Thank you.
Thank you, guys.